Hey guys, welcome to lesson 7.3, where we talk about constructing a confidence interval for a mean. This is a one sample t interval. So here's our opening example. How much do Virginia Tech students sleep? Cook Counseling Center is preparing a campus wellness report and wants to know the mean nightly sleep for Virginia Tech students. Asking every student is impossible. Same thing is we don't want to do a census of the population. So they take a random sample of 12 students. And here's the data for the 12 students with a sample mean, so X bar sample mean of 7.0 and a sample standard deviation of 0.93. So we want to construct a 95% confidence interval for the mean sleep of all Virginia Tech students. So we have a sample here. We have a sample of 12 of them. And then we want to use that to have some sort of an idea of what the average for all Virginia Tech students is. Before we do this, we need three tools. What single number is your best guess? So a single best guess for the population mean would be the sample mean. How far should the interval reach? And when we don't know the population standard deviation, with only 12 students, when is an interval like this even trustworthy? So let's look at all that stuff. So the formula for setting up a confidence interval for one sample mean is X bar plus or minus T star times S over square root of N. So X bar is my sample mean. My S is the sample standard deviation. Of course, N is our sample size. And instead of using Z for our multiplier, we're going to use T. It's a T distribution. So T distribution and degrees of freedom. It's bell-shaped, centered at 0 with a standard deviation of 1, just like the Z curve, but it has heavier tails. One distribution per sample. The degrees of freedom, so when we look for a T distribution, when we were doing a confidence interval for proportion, we used the normal distribution. Now we're going to use a T distribution. So degrees of freedom is going to be sample size minus 1. So if we have 12 students at Virginia Tech, the sample of 12 students for our sleep study, we would have 11. Our degrees of freedom would be 11. So 12 minus 1 is 11. And if we're looking, so everything else is going to be the same. We're going to look for calculated value corresponding to an area. And if we want to have 95% confidence, we would have a central area of 95%. All right. So as degrees of freedom grow, our T distribution approaches this standard normal Z distribution. So as my sample size grows, the T distribution approaches the Z distribution. So two conditions, check them first. Data has to be random, same with the proportion sample. And instead of 10 hits and 10 misses, either sample size needs to be greater than or equal to 30, which is considered big enough, or my data needs to be roughly symmetric with no outliers. So I would take the 12 students who, I would take the data of the 12 students in the sleep study, graph them, and make a box plot and make sure there's no like outliers or obvious skew. All right, so finding T star on Statlet. As I mentioned, find the degrees of freedom, put them in, put the central area as whatever you want your confidence level to be, and then have the value here. So 2.201 would be my multiplier. So there it is. My multiplier would be 2.201. So degrees of freedom n minus 1, that's one of the things you have to remember. All right, so here is my sleep study data. You can see when we graph it, because sample size is less than 30, we have to graph the data, take the data, put it into a box plot, and you can see that it matches pretty nicely. No outliers, no like clear obvious skew. So we would construct the confidence interval. Since my large count condition is check, I would do x bar plus or minus t times s over square root of n. So my sample mean is 7.0 plus or minus 2.201 times my sample standard deviation was 0.93 divided by the square root of my sample size, which is 12. So when you do this 7 plus or minus, remember everything here is the margin of error. So we have point estimate plus or minus the margin of error. And when we do that, we'll end up with this interval 6.409 to 7.591. And we would say we're 95% confident that the mean hours of sleep for all students at Virginia Tech is between 6.41 and 7.59 hours. So weekly coffee spending, 90% confidence. A random sample of 30 Virginia Tech students spends an average of $12.50 on coffee with a sample standard deviation of $4.20. So check the conditions. We have 30 Virginia Tech students. So that's greater than or equal to 30. So we don't have to check the data for any sort of spread or outliers. And we would have, let's see, we want 90% confidence. All right, so I'm going to go back to here. So my sample size is 30. So I'm going to have 29 degrees of freedom. And I want a 90% confidence interval. So 1.699 is my multiplier. And that's where they got the, let me see. Yeah, so there's my multiplier. So my formula is x bar plus or minus t times s over square root of n. So 12.50 plus or minus 1.699 times my sample standard deviation, 420, divided by the square root of my sample size, 30. So when I work that out, I get $11.20 and $13.80. So I'm 90% confident that the amount that Virginia Tech students spend on average per week on coffee is between $11.20 and $13.80. So one more example, a random sample of 25 Virginia Tech students where speedometers for a day, a box plot of their step counts is roughly symmetric with no outliers. Check both conditions. So a random sample, good. And even though my n is 25, which is less than 30, the distribution is symmetric with no outliers. The 25 students totaled 190,000 steps. Find the point estimate, degrees of freedom, and the multiplier. All right, so degrees of freedom is 25 minus 1, which is 24. My x bar would be my 190,000 students steps divided by 25 students, which would be 7,600. Have an average of 7,600. The multiplier for a 95% confidence interval. All right, so I have 24 degrees of freedom. I have 24 degrees of freedom. And I want a 90%. I'm pretty sure it asked for 90%. Nope, 95%. All right, so 95%. My multiplier would be 2.064. So my multiplier t star would be 2.064. So with this sample standard deviation, find the margin of error. So I would do 7,600 plus or minus 2.064 times 1,500 divided by square root of the sample size, square root of 25, which is just 5. But so on Desmos, I would do 7,600 minus my multiplier times my standard error, and then I would do plus. So between 6981 and 8219. So 6981, 6981, and 8219. So we are 95% confident that the average amount of steps for all students at Virginia Tech is between 6981 and 8219. That would be my calculation and my interpretation. So key terms, one sample t-interval. You've got the formula. A t-distribution is bell-shaped, but it has heavier tails. And as your sample size goes up, it approaches closer and closer and closer to what a normal distribution would look like. Degrees of freedom is sample size minus 1. T star is the multiplier using a inverse t distribution, and standard error of x bar is just the sample standard deviation divided by the square root of sample size. So estimating the mean uses this formula. Conditions has to be random. The sample has to be collected randomly, and either the sample size has to be greater than or equal to 30, or the data has to be roughly symmetric. So t comes from the t distribution applet with n-1 degrees of freedom, and central area with a mean at 0 and a standard deviation of 1. So 6 steps: check the conditions, find the point estimate, find the multiplier, calculate the margin of error, do the interval, and check the interpretation. And that is the lesson 7.3 on a 1 sample t interval.